Hello, everybody. All right, I hope you are doing well. The nice thing about today is that we are just doing a little bit of review, so hopefully this feels familiar, okay? Now, one thing I do want to tell you as we do some of the things in this part of our unit, you may be flipping around on pages a little bit. The one thing I will tell you is if you don't want to lose this and have this on a different random piece of paper, I would recommend you find page 11 in our current notes packet, and there should be, as long as things are going according to plan, an entirely blank side, all right, on page 11 for you to do some completing the square review. If not, or if it's a different page, you can always just get out a separate sheet of paper. That's just a little bit of a organizational suggestion, just so everything's all housed in the same place. So without further ado, completing the square review. So there's basically three situations for completing the square that I'm going to go over. This very first situation is, what if you have a lead coefficient of 1? Okay, so what does that mean? That means right in front of this x squared is the number 1. Even though we can't see it, that's what's there. And so, generally speaking, this is going to be your most straightforward situation. And as a reminder, we are completing the square, meaning we're turning something that is currently in standard form into something that is a quantity squared so that it looks more like vertex form, okay? And the way that we're going to do that is we're going to move this c value. So we're going to take this this negative 2, and we are going to add it to the other side. So right now we've got f of x plus 2 equals x squared minus 4x. And I'm going to toss a blank on this side, and I'm going to toss a blank on the other side. Now, what goes in this blank on the right-hand side? Whatever b divided by 2 squared is. Now, this requires you to remember that technically this first letter is a in front of this x squared, that this term in the middle is b, and what we are ultimately looking for is c. So in this particular problem, if we take negative 4 and we divide it by 2 and then we square that, we get 4. Now, why did I put a blank on the left-hand side? Well, any good mathematician knows that if you do something to one side of your equation, you better be doing that to the other side. So we're going to add that 4 to the other side. And now we have f of x plus 6 is equal to x squared minus 4x plus 4. And at this point, we now have what is considered a perfect square on this right-hand side. So we're going to factor, and it should factor into a perfect square. That means one quantity squared. So we are going to get f of x equals, and I'll explain why I'm saying equals in a second, x minus 2 quantity squared, because that's how this trinomial factors, okay? Now, why am I saying x minus 2 squared equals f of x? Because I'm also going to move that 6 back over. Now, just so you know, for the purposes of this particular unit that we are in, the key steps are that you know how to rewrite this c value and add it to both sides, and that you can factor into a quantity squared. All right, that is the biggest thing you're going to need to be able to do. Moving that k value back over, not as crucial in this particular unit that we're about to start. Okay, so that's what you do when the lead coefficient is 1. What do you do when the lead coefficient is something other than 1? Well, you start off the same way. You still move your c value because it's probably not the c value that you need in order to make this a perfect square. But you do one additional thing, okay? This leading coefficient, you factor it out of your remaining 2 terms. So we're going to take that 3 out, and we're going to be left with x squared plus 4x. And we're going to put the blank inside the parentheses this time, all right? Inside the parentheses, because that's where our x is. We put that blank wherever our x terms are located, okay? Technically, in this other problem right here, you could have thought about this trinomial as if it was in parentheses, but its lead coefficient was 1, so it's not like you really need those parentheses. Okay, so then we do the same sort of thing to fill in this blank. We take our b value, divide it by 2, and square it. And keep in mind, It's the current b value. So a is 1, b has now been switched to 4, and we're looking for c. And that c value is going to end up being 4 once again, because positive 4 divided by 2 squared is still 4. But here's the big kicker, all right? Here's the big change. I'm going to get a different color. We added 4 inside the parentheses, but really what we added was 12, okay? 3 times 4. So just maybe a note, if the lead coefficient is greater than 1 or negative 1, the first thing you need to do is you need to factor it out. And remember that when you add on this side, you're adding a times c, meaning you're taking this a value of your original problem, multiplying it by your new c value. So really we're adding 12 to that left-hand side. So now, just to recap, we have f of x plus 11 equals 3 times x squared plus 4x plus 4. And the reason why you have to add that 12 is because this equal symbol means that these two sides are supposed to be equal. Well, if on this side you multiplied the 3 in here, you'd get your 3x squared, your 12x, and you should get 12. But you wouldn't get 12 to match up if you didn't add that to the left-hand side the way that you're supposed to. So just a little heads up on that. Okay, and then from here, the rest of the work's going to be the same. You are going to once again factor so that this is a perfect square. So this is going to be x plus 2 squared with the 3 out in front. And then f of x is going to be equal to that, and we would subtract 11, okay? I do want to point out that if you haven't noticed this pattern in other problems when you were completing the square, the middle sign will always be the sign of your factors. So negative sign here, negative sign in my factors right there. Okay, so last scenario for you, and then just a little bit of wrap up. So third scenario is what happens when the factor is negative, okay? My leading coefficient is negative. So again, same step to start out, we're going to add 4. So y plus 4 equals. By the way, at any point, if you need to pause this video or go back, if you haven't done that already, to write down the problem, please make sure you do that, okay? And make sure you're listening to the explanation, because that's really the important part of this. And I say that not only for this video, but for every video you watch. You should constantly be pausing it to kind of process and think about what you're listening to. Okay, so with that in mind, we're moving that 4 over again. And as with the last problem, this leading term is not 1, so I'm going to factor it out of my remaining 2 terms. That is going to do a couple of things. First off, it is going to change this sign in here, all right? Because the only way to get a positive 12 is if I have a negative times a negative. So it's going to be negative 4x. Now, that isn't going to really affect my c value that goes here in these parentheses. But hold on, it is going to affect something. So again, b divided by 2 squared, and it's my current b value that's in the parentheses. That's the one I'm using to find a new c value that goes in the parentheses. So again, it just so happens that we keep working with 4. It won't always be 4. I do want to make sure you know that. Now, as I told you, this blank over here on the left-hand side is supposed to be a times c. So this might seem a little bit counter to what we've been doing. If a times c is now negative 3 times 4, then you are going to be adding a negative number. Okay, but if you think about it, what did we add on this side? Well, we added in the sense that we included a negative 12. And so to balance out my equation, I need to include negative 12 on my left-hand side also. So then, just to sum up, I've got y minus 8 equals negative 3 times x squared minus 4x plus 4. And now I'm going to take this opportunity to just remind you that if you're trying to figure out, well, why does this factor the way it does? Well, we made it so that this number, c, is the middle term divided by 2 squared. Okay? So that means it will always work out that if you divide that middle term by 2, so if you divide b by 2, that when you write that number twice, so negative 4 divided by 2 is negative 2, so write it twice. When you multiply that out, you're going to get your c value. And then x times x is always going to be my x squared. So that's why it's negative 3x minus 2 quantity squared. And then technically we're adding 8. But like I said, the big part is going to be being able to get to this point, all right, where you can factor the quadratic, okay? Because we are going to be moving to a situation where you're going to be completing the square more than once in a given problem. Okay, so to sum up what we have done here is a little bit of review. The first thing you want to do is you want to move your current c value, all right? You want to move it to the other side, get rid of it. The second thing you want to do is factor a out of your remaining 2 terms. And just as a heads up, that is only if a doesn't equal 1. Okay? If a is 1, you don't need to factor it out. It wouldn't do anything even if you did. All right, then the third thing you need to do is you need to find a new c value, and you do that by taking b divided by 2 and squaring it, okay? And you want to make a note that you're going to add to both sides. And if a doesn't equal 1, you should add a times c. To, in this case, it's my left-hand side, but it's to the other side. It won't always be that you're completing the square on the right-hand side. Just so whatever side you're working on, you add a times c to the other side. And then your fourth step is that you're going to factor into perfect squares, okay? So you're going to have some quantity squared. Now, I do want to keep in mind, these are, and I spelled this word wrong. I was thinking about too many things at once. Move current c value. These are the things I think about, and this is how this process makes sense to me. I move c, I factor out a. Find my new c, I factor again. It's kind of a bouncing between deal with c, factor some stuff out. Deal with c again, factor again. This is how it makes sense to me. If this process doesn't make sense to you the way that I've specifically written it, then make sense of it yourself. And if you're unsure, email me or ask me about this process, and we can come up with a way that makes sense for you too, okay? Because this is going to be really important throughout the remainder of this unit. So that's all I have for you today. Enjoy the rest of your day. All right. Have a nice day. See you soon, hopefully. Adios, people. Bye.